Hi everyone again. So yeah, I am also well, a bit excited to see so many people here in the hall. Not well, too many opportunities in the last 3 years to be in live. So yeah, thank you for visiting us, and thank you also participants in our webinar. Yeah. My presentation will be about statistics. It is a very interesting subject for me. Yeah, it is also a very powerful tool, but I think it requires some background to use it, and especially to use it in eazyBI. So my name is Jānis. And in this presentation, I collected different cases that are related to the application of the statistical methods, statistical functions available in eazyBI. Yeah, I am working for eazyBI support team a bit more than 5 years. And I think reporting is very much the hard discipline. And in many cases, the background in mathematics could help you much. And several of my today's use cases should also be related to that. Well, such use cases is what I like to do. And so it is very interesting to see how to do that with eazyBI. Well, before I start, I wanted to mention that, of course, there are specialized tools for statistical analysis, and statistics is not the primary domain of eazyBI, but we can cover several interesting statistics cases also in eazyBI, or just look on some other well-known use cases from this statistical perspective. So that is also what I will touch today. And first, I will tell about several out-of-the-box things that most of you might have tried already, but they are still very much recommended and very, very useful for regular use. Then I will switch to perhaps less often used features that have background in statistics. Those are interval dimensions and scatter charts. And finally, I will touch a couple of more, even more interesting use cases that you can achieve with eazyBI and with the custom measures of eazyBI. And so I will refer to some interesting formulas and some interesting functions of MDX language. Yeah, but before going in the serious stuff, so I always recall this joke, which is often mentioned, that, and this is perhaps the most familiar joke about statistics, that statistics is often used for lying. My colleague Jānis will later touch this topic in more detail. But I think that this is statistics properly used is not for lying. The problem is that in many cases people misuse this tool, and they asked Google for help to dive in more details about these lies, big lies, and statistics. Yeah, no one actually knows who said it, either Mark Twain or some British Prime Minister. But yeah, the problem is that statistics must be used properly and must be interpreted properly. So yeah, statistics is a complex subject, but statistics usually starts with a straightforward indicator of average. So everyone knows average. And eazyBI Data Cube provides several out-of-the-box components for use in your statistical reports with averages. Those are, you can search those measures by typing average. You will find quite a long list of them. And those are all efficiently working formulas, and it is recommended to use them and maybe borrow ideas how you could construct your own average functions if you need some specific. Well, one thing that you might notice at the formulas of the standard measure is that average should be always possible to express as a ratio. Ratio of the total of the measure to the number of the elements divide. Well, but not always it is possible to have the measure for calculating average as a ratio. There could be no standard measures for this ratio, and we might need to write use this MDX function, which is maybe more flexible but less efficient, and there is an average function for making your custom averages. So here I have an example of how to rewrite the function of average resolution days, which is standard measure to the same equivalent function using this average function. This average function is useful to know that it requires two parameters. One is the set over which you calculate the average. In my case, this is a set of resolved issues. I filtered here issues by the resolution, and then take total resolution days, and those functions work equivalent. So, but the point is that whenever possible, you must try to use it as a great average as a ratio, and maybe you will step in some advanced areas of eazyBI. You might need JavaScript for some measures to make efficient averages. So. There is even a simpler way to implement averages at the report level. Gerda already showed an example. I will show it again. So you can add this standard calculation when you click on the column header of the measure. So, and let us have a look on some small recorded demo of 1 minute, how I create and what seems interesting to me. I added the time dimension and expanded it to the monthly level and kept the same issues created measure, the default measure, and put the calculated statistical average among other functions that are average. So, and I have average over all my rows. So this feature works as on visible rows. So it may not be the most useful use case. So I may need to apply the page filtering to select 1 year. And you see that average always adjusts to the filtering. The same function can be reused if I would like to see average number of stories under epic. So I select epic hierarchy and I see the average of stories under epic. I can filter it by project and I can, it all the time adjusts. So perhaps I don't need this no epic row. So I remove and the average is always adjusted. So that is how the standard calculation on the report level works. It always adjusts to the visible rows. So, but let us continue with this beautiful feature of the add calculated. So now we can create this average of issues created, but we may also wish to see, here is my selected 1 year of number of issues created, and well, this is not always evident if this number of issues is growing or maybe declining. So, and there is one more very actually statistically based solution. You can add, well, of course, first you can add the same average, but you can, well, let us switch to bar chart. Average is always by default shown as a solid line. So, but we can build this excellent feature, use linear trend. So it is, there is a complex statistical model behind the linear regression, and you can check the formula, how it generates formula of MDX for that. But the visible result is that we can see the trend of our bars in our report. So this complex concept is implemented with a couple of clicks in eazyBI. Well, another perhaps quite often used feature is this interval dimensions. And if we think a bit, then it has relations to some statistical background. So often when we talk about statistical data, very important question is how this measure is distributed. In other words, where we can expect the values will appear the most likely. And scientists have built a lot of theory behind that, and there are a lot of invented many standard distribution patterns, and did a lot of research, and that's so that our life is easier now. And there is a feature, and interval dimensions is this feature that allow to have distribution charts, or our customers sometimes refer to them as histograms. So let's have a look on that. There are two interval dimensions which you can create in eazyBI by selecting data import option. It may be by default already selected, but if you do that, then two additional information dimensions are created. First is the issue age interval or issue resolution interval. So here is a bit more details behind that. Age interval is actually measure which counts difference between the issue creation date and now. Issue resolution interval is the measure counting the difference in days between creation and resolution date. So of course for the resolved issues only. And well, the simplest useful report is that we can add resolution interval dimension to the report, and using the issues resolved measure, we can see in the bar chart the distribution of issue resolution days. So yeah, you may need to not always, by default, this interval dimension is created with the even ranges, but you can configure if for your use case that intervals can be very flexibly adjusted. So for instance, I have 5, 10, 20 or 100 resolution days interval, and build my histogram not on even but on any custom ranges. Well, interval dimensions can be extremely useful not only for your statistical distribution reports, but also when thinking about some optimizations. There are certain use cases that can be quickly achieved using complex and maybe not always efficient NDX formulas, well, which later can reach some performance problems. For instance, if I wish to find the issues exceeding some number of days in specific status, here is again my formula with using descendants and filter and count. So just to check if the count issues exceeding days in transition status in the progress status more than 5 days. It would be much more efficient formula if I could rewrite it as a tuple where I can take issues and find those issues if I had a dimension with 5 or more days in the status. So that is possible in eazyBI also, and always we often use as a optimization when customers ask. So we can create with JavaScript our custom interval dimensions. In this case, I created some JavaScript code which pre-calculates the days in progress status. And then I have my eazyBI JavaScript calculated custom field, and it results in the dimension which I can configure to cover my range of issues with optimized formula. Yeah. There is one more widely used concept in statistics, the correlation. Many of you might know that this is basic meaning of this concept is the interdependence between two variables. This picture shows the idea, so that correlation between two variables can be calculated as a single number in the range of -1 till 1. And in some abstract terms, it means how flat is the scatter between those two, how flat is the cloud when we put those two measures on X on Y axis. So here we can see that if it is 1 or -1, the flat scatter is actually a line. So, and depending on how flat is this cloud, it is this correlation is lower. eazyBI offers the scatter chart for showing how two measures relate each to other. And this scatter chart requires 2 or 3 columns. So if you create 2 columns, this is the measure for scattering. eazyBI can interpret also the 3rd column and show this scatter chart in a bubble, as a bubble. This is a bubble size, the 3rd. Well, I have here an example of one use case. Sorry for maybe not too good resolution here, but this is the days in one specific status, which is in one column. And here is some custom measure counting the customer votes for this ticket. So, and when I put it on the scatter chart, I applied some size calculation here, also bubble size. We can see that this scatter doesn't look like having high correlation between days in some development status and how much customers have requested this ticket. So, but we may have a look on another case where we would expect higher interdependence or higher correlation. For instance, when I put on the scatter the hours spent on issue and the resolution cycle time or resolution days. So here I have some test data, and even if visually it looks that this scatter is somehow quite compact. And here is an example formula. There is not a very well-known function in MDX that can calculate correlation. So I use the same 2 measures here as parameters in this formula, and it calculates the same scatter in the one single number of correlation. So it shows in my example 0.63, which is quite reasonable, significant correlation. So, but just to illustrate, I took one more example here when I put on 2 axes the original estimate versus actual hours. So it usually shows even more compact more compact scatter. Well, this is actually, when we recalculate it as a correlation, now shows 0.9, which is very good. And well, perhaps this correlation is our alternative way of how we could evaluate our estimation accuracy. So often it is recalculated in percentages, so we can have this total hours spent and total estimates, but correlation is also maybe another way how to do the same. Yeah, and now my final part is that about the other useful MDX functions and a couple of use cases where you can apply those functions in your use cases. So let us have a look on an overview here about the functions which if you are interested in statistics, you may try out. First is that, average, I already mentioned, but well, average might not be always the can be actually misleading thing, especially if we do not know much about how our variable is distributed. So average is only one thing, and often very useful is this median concept, median calculation, which shows what is the number value of at least 1/2 of the variable items. So, and this is one just one function of the wider set of similar functions of MDX. You can see also quartiles, and you can see also percentiles, which, and to split this distribution in more by percentages. MDX language also provides option to calculate deviations. You can have variance and standard deviation. And I mentioned already, we saw a simple solution on how to create your linear trend, but in some cases you might need more specific. So you can use this linreg point, which is linear regression. You can have one single number of calculating how steep is the linear trend. This is linreg slope, or you can have also a very interesting function of linreg variance, so that shows the difference between each item to the linear trend. I can also suggest you checking one site, which is the documentation of all the functions which is included in the MDX engine, which we are using in eazyBI. So those descriptions may not be too expensive, too comprehensive and too detailed, but you may find some function that I didn't mention, but might be useful for you. Well, now a couple of use cases. Here is one customer who asked us, I didn't know earlier, this name, excellent name of Monte Carlo chart, that you can actually, this basically is built on just on resolution interval dimension, which is put on the report on the x-axis. And the idea of this chart is that we can highlight the ranges which correspond to some total percentage of all the items. Here we can calculate which is the first 25% of all the issues, all those bars in total below here have 25% of total, and maybe 75%. So, and in the middle we have some 50% maybe, yeah, of issues that are within this some middle range. So you may also notice that this report uses conditional formatting mentioned by Gerda, but what is even more important, there is quite a tricky formula to extract the range name in the numeric value and compare it to this quartile calculation to have the option to highlight those middle parts. So this beautiful chart is in our demo account. You can check it and formulas behind them to see how you can implement your use case in Monte Carlo chart. And finally, I have at least 2 customers who asked for Six Sigma report in eazyBI. Well, those who haven't heard, this is the use case comes from manufacturing domain. And this is the idea that if you have reached some reasonable level of some KPI in terms of averages, you may go to the next level of process maturity and try to limit the deviation. So to have more predictable some measure results. So, and this idea of the Six Sigma report or Six Sigma control is that not too many cases should deviate from the average for too much. And there is one widely accepted criteria for that, that 95% of cases should not deviate from the mean for more than 3 times the standard deviation. That's quite a long definition, but yeah, here we can have just 2 formulas for doing that in eazyBI. First, we can calculate average. I didn't include that here, but here is the formula to calculate the standard deviation on the left. Yeah. And then I used some abstract measures of item values. Yeah, this is some numeric, for instance, custom field from JIRA issue. And then you can have a count of issues which do not deviate from this sigma or standard deviation more than 3 times in both directions, which is what means 6 sigma. Yeah. So, and well, maybe you can have useful report on the project level to find which projects are in 95% 6 sigma criteria or which do not. So in my case, yeah, one of those projects needs some better predictability. So now to finalize, I hope those examples can provide you with some new ideas for some interesting reports. And just to remember that the add calculated is a very useful feature. You can have interval dimensions and scatter charts for some statistical analysis. And there is a lot of MDX functions for statistics, which may cover more and more interesting use cases.